How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we're going to be working on this 8-ton forklift, and what we're going to be working on is replacing the bushes in the top of the tines that allow the forks to be moved left to right. So this forklift's used by a transport company for loading and unloading containers and trucks. They are actually a local company, so they were able to throw the whole forklift on a truck and bring it down to us so we could work on it. So on this forklift, the tines are hydraulically positioned, which means from sitting in the seat, you can move the tines in and out to pick up odd size loads. Not all forklifts have it like that. My forklift, you have to do it manually, but the reason they do it on these bigger forks is the tines are very long and they're extremely heavy and you can't move them manually. So to prevent steel on steel contact, there is supposed to be a bush in the top here, which allows the tine to move freely. But the bush is actually completely gone on the right hand side, and the left hand side, we're not sure what's still in there. So what that means is there is a lot of movement when they're trying to position the tine, and they tend to bind up when they go to move them into position. And because there's no sacrificial bush in there, it is going to be wearing out this boss and the shaft. So what we're going to need to do is make up new bushings and retaining plates and get them installed into the tines. But the first thing I need to do is get the tines removed off the forklift. We'll also be keeping our eye out for anything else that needs repair. So I'm just going to move the position of the forks all the way out. That way I've got access to the cylinder rod that holds onto the fork tine. So those pins came out pretty easy. I'm just going to retract the cylinder rod so they don't get damaged. So now I'm just going to remove the retaining plate so I can remove the shaft. Now with the shaft removed, I'm just going to back the forklift out of the tines. So now I'm just going to remove these retaining plates, then I can knock out the rest of that bush, then I'm going to clean everything up and I can inspect the bores.
Oh my god.
I think it's a bit bent. That's the bush. plastic. So I've cleaned these up and I have taken some measurements. There is a little bit of wear on the back side of the bores, but that is to be expected considering what these do and where the load point is applied to. The right hand one is actually in pretty good condition considering there was no bush in there. So typically any other component that has wear in its bore, we would line bore it and bore weld it back to size. But because forklift tines are a very high tensile material and after they've been manufactured they do get heat treated, I don't want to upset that because any heat I put into that could affect the structural integrity of the tine. And considering this is an 8-ton forklift, I don't want to run the risk of this failing. So if we had the time, I would line bore these back to size and then send them out for heat treatment. But I have spoken to the customer and he's not interested in doing that because he does need this machine back tomorrow. So he has asked us to just re-bush these and reassemble the machine. So now we can go over to the lathe and machine up the new bushes. So the material we're going to be using is acetal. It is an engineering plastic that is used in high load and high cycle situations, which is going to be perfect for what we're doing. So the starting diameter of this rod is 90 mil. We do need to turn down the OD, but before I do that, I need to drill out the inside and bore it to size. So to drill the hole, I'm going to be using a BPK spade drill with a 65 mil insert. So we are wasting a lot of material by drilling out a solid, but I wasn't able to get a hollow bar. Now I can go in with my boring bar and bore it to size. So next thing I'm going to do is I'm going to turn the OD to size. So that's our OD turned to size. I'm just going to chamfer it, machine in a grease groove, and then we can part it off.
What's that? Get it, get it! Hold on. Hey? What do you got? Let's go.
Righto guys, so that's our 2 bushes made. I still need to drill in grease holes. We'll do that before we fit them, but the next thing I'm going to do is machine up the retaining plates. And the piece of material I'm going to be using is a piece of 140 OD by 70mm ID hollow bar. So because this doesn't fit down the spindle of the lathe, I am going to have to set up the steady. I'm just going to machine in a steady band and get that set up. So I've taken a clean up cut and that's measuring at 138mm. It needs to go down to 122, so that's 16mm off the OD. So that's the OD machine to size. Now we're going to bore the ID. So the measurement on the ID that we're aiming for is 76mm, and that will give us 1mm clearance around the 75mm shaft. So I've done a clean-up cut, and that's measuring at 74.2 mil, so we need to take out 1.8 to bring it up to our 76. So now I'm going to go in and mark the parting off length for the 4 plates, then I'm going to chamfer the edges and part them off.
I know.
Right, come on.
Whee! Oh. Bye, George.
So that's our 4 retaining plates machined. Now I just need to set them up in the mill and drill the holes for the bolts. So that's the bolt holes drilled. I'm also going to drill the grease holes in the bushes, and then we can get all of this reassembled.
Hey. Let's go.
So I'm going to be using Loctite on the bushes when I install them, even though I have put a 0.3 of a mil interference fit on the bushes. Because they are a very thin wall and they are an engineering plastic, I should just be able to tap these in with a hammer. Putting any more crush on them than that, I would probably run the risk of cracking them or damaging them when I'm putting them in.
Looks much nicer.
So those are all fitted. That looks much better now. I've also gone ahead and done a quick inspection over the cylinders and over the mast just to make sure there wasn't anything that was on its way out. So that looks all good. Now we can fit the forks back to the forklift. So that went in without too much drama. Next thing I need to do is refit the pins for the fork positioning cylinders and fit the plates that retain the shaft into the mast.
Anything but a hammer.
So now we're just going to cycle it a few times to make sure everything's working correctly and nothing's binding. Righto guys, so everything's working exactly as it should be. The tines are moving nice and freely along the shaft. It's no longer kicking over or binding. So for about $100 in acetal and a couple of hours work, we've got this machine ready to go back and move stuff. Thanks for watching. Righto, so I've cleaned those up and I've whipped out the ID with the die grinder. I've taken some measurements So I've cleaned those up and I have taken some what was after that? So I've cleaned those up and I have taken some measurements. Oh fuck, I did it again. So, oh wait, what?
And
What was after that?
2.
So the diameter of this is 90 mil. We will need to turn down the OD, but the first thing I need to do is drill a hole. Oh fuck me, I'm having a problem.
You're really doing good.
Thanks. I feel like I'm just doing well. So to drill the hole, I'm going to be using a 65mm BPK. So that's our 4 retaining plates machined. Now I'm just going to set them up. So that's our... And the material I'm going to be using is a piece of 140mm OD by 70mm ID.
That ain't right for you. It's an Easter bunny. Is it? Put your head down. You have glasses on your hat. Yeah. It's like it's magnetic.
Static.
Static, that's what it is. No quick change here, guys.
I used it elsewhere.
Not so quick change.
Sometimes they just won't chip at all. Doesn't matter what material you got in there.
Hey. Tug of wars.